Solve linear equations containing decimals. By the way, everything still works the same. Your principles of equality, whichever process you want. Like if you wanted to use the switch and stay game, you could. But again, the process for the most part is you distribute, you combine like terms, you isolate the x's, you divide by the coefficient, bam, and then you're pretty much done. So a problem like this one, again, I'm just going to solve it the same way that there's a one-stepper, you guys. I want that x by itself. I want it to be x equals something. I don't want anything added to it or subtracted to it. I don't want anything multiplied or divided by it except 1. And right now it is a 1. It has a coefficient of 1. I'm just making it a phantom 1. So I got to get rid of that 29.478, which is positive. So I'm going to add its opposite, which is the same as just subtracting 29.478. I just need to do it to both sides. So subtract 29.478, and if you'd like you can do this by hand, but I'm going to turn straight to the calculator and do this, which you guys can see on your screen. 12.84 minus 29.478. I think I typed that in right. So that's going to be x equals negative 16.638. I mean, if you want, you could say negative 16 and 638 thousandths, but most people don't really go that far in it. And you know, we can check, right? I've already got it pulled up on my calculator. So negative 16.638. What do we get when we add 29.478? 12.84, which is exactly what we would expect, confirming that this is the solution to this equation because it makes the original equation true. Alright, so two-step equations, just like this one, it's going to work exactly the same way. Again, we got p's in this case, so if we can isolate those p's, then we'll be in good shape. We just want the 2.4p for now. So I don't want that negative 6 there, so I'm going to zero it out by adding 6. But I'll add 6 to both sides. That zeroes out. We'll drop the 2.4p. And then this equals, it should be negative 2.7 there. And finally, we'll make the coefficient of p a 1 by dividing both sides by the coefficient that it is right now, 2.4. And that'll tell us what p equals. So again, I'm going to go to the calculator. Negative 2.7 divided by 2.4 equals negative 1.125. So negative 1 and an eighth right there. But again, I'm just going to check. We're going to do negative 6 plus 2.4 times negative 1.125. I did that right. Negative 8.7, bam. And that confirms that this is the solution to that original equation. These problems are getting kind of bigger, kind of like that first one that we had a question on. And yeah, we may still return to it, but we see they're getting bigger, and of course we're not seeing any distribution right now, or even combining like terms yet, but I assume we're going to see that eventually. So on this problem, and I'll just ask you guys, which side do you guys want the m's on? So I'm going to keep the m's on the left, which means that this negative 3.4 is on the wrong side. It doesn't have an m, but all my m terms should be on the left side of this equal sign. So I'm going to zero that out by adding its opposites. But again, I'm going to show it as plus 3.4 on the other side as well to maintain the equality piece of this equation. So right now that changes it to 7m equals 5.8m. We got that plus 0, but it's a phantom 0 now. And 6.12 plus 3.4 equals positive 9.52. So now I reevaluate and I see 5.8m, it's on the wrong side of the equal sign as well. So I need to zero that out by just getting rid of it. But I need to subtract it, that's going to make that 0. I need to subtract it from both sides of the equal sign, which is going to make that a 1.2m equals, and I'm just going to drop that 9.52 there. So finally, we're at the one-step equation part where I'm just going to divide both sides by the coefficient 1.2. Again, that's to make that a 1m. 1m now equals, well, I don't know that. I don't know my 1.2 division tables very well, or my 9.52s for that matter. So 9.52 in the calculator divided by 1.2. Now, if you guys wanted to do that by hand, you could. I'm just not going to. Now, this would show as 7.93 and the 3 repeats. Maybe this one should have said that we should have maybe rounded somewhere. I can keep it in bar notation like this just because it's more exact. Actually, before I box that in, let's go ahead and check. So I'm going to do this a little different. So you guys see on the calculator, right to the left of, not right, just immediately to the left of 1 is the stow arrow button. I pushed that, and then right above it I pushed the X. Okay, that means, and you guys see on the calculator how it shows ANDS, that's answer is going to store for X. So the calculator knows that I want 7.93 repeating in for X. I don't know what the fraction is, and I don't really care because the calculator knows exactly what that value is. Now when I go in and type in my equation, I'm going to use X instead of M. So I'm going to type 7X for me minus 3.4, and this is going to tell me what it equals. 52.13 repeating. Now I'm going to go to the other side of the equal sign, and it should, when I evaluate it, equals 52.13 repeating. So 5.8, and I'm just going to put X instead of M, plus 6.12 equals, there you go. See how it's the same answer for both, and that confirms that this is the solution for this equation, but it also reduced the amount of buttons I need to push. I didn't need to round. I did not need to estimate. Okay, it's an exact value on that it gave us, and again it confirms. Otherwise we could say, well, you could be a little bit off, which is true if I had rounded that. Okay, but we went with the exact value and we forced the calculator to do it exactly. So finally, we see one with some distribution, and again, I'm going to be turning to my calculator to do a lot of this calculation stuff for me. Because I know, again, I should be looking to do any distribution first in these problems, and we got it. There we go. So I'm going to type this into the calculator. I've got 0.5 times 0.25, and that's going to tell me how many x's I have, 0.125 x's. Now I need to distribute that to the negative 2, so 0.5 times, I'm just going to put 2 and know that it's negative right there. It's going to show me 1, but I know it's minus or negative 1. And that distributes that 0.5 into that set of parentheses for us. Now this next one we have to be very careful with because it's not 0.125. That is a negative 0.125, all right? So I'm going to even type it into the calculator that way, negative 0.125. Oh, whoops. I'll go back. There we go. And I need to multiply it by 80 first, which is going to show me negative 10. Now I'm going to write it as negative 10x, knowing that that negative is going to carry the operation of minus for us. But then we have negative 0.125 multiplied by, again, this would be negative 7 right there. And that is the number of x's. And that shows, well, I guess a decimal on that one. But it's positive now, 0.875. You know, I should have noticed this. Some of you guys probably did. But I could have combined these two like terms right there. And if you saw that, you're welcome to do it. Okay. I'm just going to keep it the way that I have it just because I guess I've already started it. But yeah, this is going to equal negative 46. Well, yeah, now there's lots of like terms to combine. Well, lots of x's to combine. And it's showing we got 0.125, it was positive, and then minus 10 of those x's, and then plus 0.875 of those x's. Shows us that that would result in negative 9 x's. I'm going to drop this negative 1. I didn't have any other operations to perform on any like terms to combine it with. And then this equals negative 46. Well, this looks like a pretty nice two-step equation, actually. So I'm going to isolate the x's by getting rid of that negative 1 by just adding 1 to both sides of the equal sign. So that zeroes that out. Drop the negative 9x. This equals now negative 45. But I don't want negative 9x's. I want 1x's, so I'm going to divide both sides by negative 9, the coefficient, to make that 1x. 1x equals negative 45 divided by negative 9 is going to give us positive 5. But again, I am going to check my work. And I see there's a question. I'll get to that, okay? Let me check my work on this. So I'm going to type it in 0.5, and you guys see the parentheses on that, right? There's my parentheses. Then I got 0.25, but I'm going to multiply by x, which I think is 5. And I didn't replace x or stored x into the calculator on this one, just because 5 is a pretty easy button to push. So minus 2, now close the parentheses, and then minus 0.125, open a set of parentheses, and then it's 80 times x, which I think is 5 right now, if I did that right, minus 7 times 5. Yeah, just close those parentheses. And when I push equals, we should get negative 46. Bam, we did it. So that confirms that x being 5 would make that original equation a true statement. I would start by distributing, doing all the distribution that I can, right? So I'm looking at distributing this negative 0.4 into this set of parentheses. Now again, I'm just working with this, typing it all in. Negative 0.4 times 0.3, and that'll tell me how many n's we have, which on my calculator is showing as negative 0.12 of those n's. But then I also have negative 0.4 multiplied by, again, I'm going to show that as negative 0.2. And it comes out positive, which means it's going to end up being plus. Now we should know that negative 0.4 times a negative 0.2 is positive. But it's important that you remember to keep the sign on that, just in case we do need to end up combining any like terms. Now we do have that minus n right there. And then it equals the other distribution, which is just that negative 1.1. And if you'd like to see that coefficient of n right there is 1, that's fine. In fact, if you want to see on the other one, you can put it there as well. And we may use it. But you don't have to. So this is negative 1.1 times 1. Anything times 1 is just itself. So negative 1.1n. And then this is, again, some of you guys know this pretty quick, but negative 1.1 times, again, I'm going to show that as negative 0.1. In the calculator, it gives me a positive 0.11. So this now is, well, it's slightly simplified. I wouldn't say that it's smaller, but at least there's no distribution in this problem now. And now that we've done that, we can look to combine any like terms that we have, such as these n's right here. Now that's negative 0.12 minus 1, and you could type that into your calculator, but it's going to give you negative 1.12. That's how many n's we have. Now I still got that plus 0.08, which equals the stuff on the right side of the equal sign, negative 1.1n plus 0.11. So again, I'm forcing this equation to be even smaller until we figure out what just one of those n's is, or I don't know. But yeah, we've reached the point where it's like, you know, which side do you guys want the n's? It doesn't matter which side you choose, but which side? Let's do it. Now I like that choice of putting this on the right because it's going to give us a positive coefficient, which is, I don't know if that makes it easier, but I just like to see positive numbers. I don't know, as well. So yeah, let's do that. So I want my n's on the right side, which means that purple negative 1.12n, it's on the wrong side. I need to zero it out. So I'm going to add 1.12n. But again, I got to do it to both sides, plus 1.12n. That zeroes that out. That's good. And we got negative 1.1n plus 1.12n, which, all right, so that's good. The calculator shows. And now I'll write the rest of this equation, 0.08 equals 0.02n plus 0.11. But again, I've got a term on the wrong side of the equal sign because I want all my n's on the right side. But as of right now, we got this 0.11 and it's on the wrong side of the equal sign. So I'm going to need to zero that out as well. So I'm just going to subtract it from itself. Minus 0.11, which will zero that out. And that's going to make a negative 0.03 right there. And this equals now 0.02n. We're really close, you guys. Last thing we need to do on this is to make that 1n instead of 0.02n. So I'm going to divide both sides by 0.02. Anything divided by itself is 1. That's good. So that's divided by 0.02. Let's see what that is. So it was negative 0.03 divided by, that's positive 0.02 equals negative 1.5. I need a little bit extra space on this. See if I can get that to work. There we go. So now n, or 1n, equals negative 1.5. But let's check. Okay, now that was kind of a long problem to begin with, so I am going to use the storage in the calculator to do this. So again, I've got the negative 1.5. I want it to just be the answer stored in for x. So I go to the left of 1 where it says stow arrow. So it's highlighted in red there for you guys. But if I go above and push the X button and push enter now the calculator knows that I want negative 1.5 in for x. So I'm going to type this in, instead of with n's, it's with x's, which is negative 0.4. And it's got that open parentheses. Then it's 0.3 x in this case, minus 0.2, and I'll close that parentheses, and then minus another x right there. And when I push equals, I don't know what it's going to give us. 1.76, that's good. But I need to evaluate the other side of the equal sign. Negative 1.1, open parentheses, again I'm just going to push x, minus 0.1, close parentheses. And when I push enter on this, I should get 1.76, bam, there it is. So that proves for sure that negative 1.5 equals n. That's going to, when we replace n with that value, it makes the equation a true statement, therefore it is a solution. With a problem like this one, again, the first thing we should always be looking to do when we, and it may be the same on this, but just make sure you're distributing that. So let me pull up that calculator again. Oh, and the problem. There we go. So I got 7 times 1.5 x's. Oh, I didn't type that in. Let me try that again. 7 times 1.5. And that's going to tell me how many x's I got. 10.5 x's. So yeah, that was good. And then we got 7 times, that's a negative 5.2. Which is negative 36.4. At least that's what my calculator says. This equals negative 110.95. So now that I've got this, I just need to get rid of that negative 36.4. So I'm going to add 36.4 to both sides of the equation. So plus 36.4. And, I could do that long addition right there. I'm not going to, though. I'm just going to use the calculator to figure out what negative 110.95 plus 36.4 is. My calculator says negative 74.55. Alright, now that we have it, at this point, we just don't want 10.5 x's. We want 1x, right? Yeah, that's what you got there. So now divide both sides by 10.5. And I'm assuming the decimal here is going to look pretty ugly once we're finished. But let's find out, alright? So I'm going to type this into the calculator. I got negative 74.55 divided by 10.5. Yeah, negative 7.1. Bam. So we'll distribute the 0.4 into this parentheses first, right? And that's going to give us, well, 0.4x. Because it was 1x right there. That's not too bad. But the next decimal, we're just going to type that into the calculator. 0.4 times, that's positive 1.6. So that's a positive 0.64, at least according to the calculator. Now I did not touch that 0.5x, so I'm just going to keep it there. Equals, and yeah, now we got this other distribution. But again, multiplying by 1 is not too bad. That's a 1.3x right there. Then I got 1.3 times a negative 1.3, which I don't know by heart, but looks like it's a negative 1.69. And then we got that plus 4.57. There we go. All right, so that's at least a little bit simplified right now. So after distribution, again, we should always be looking to combine any like terms that we can, and I do see some on the left side of the equal sign. I see some on the right, but we'll get to that, okay? One at a time. So I got 0.4, sorry, let me start that over. 0.4x plus 0.5x, which is 0.9x. Now that's positive. I'm just going to put the 0.64 on the left. I don't know why, just because I can, I guess. And this is going to equal, yeah, we got some stuff we can combine there with these like terms, the constants. That's a negative 1.69 plus 4.57 right there, which is positive 2.88. Positive right there. So we got 1.3x plus 2.88. Now, whichever side you choose for x, I'm just going to go with the left. Most students actually do just end up putting them on the left, which means that as of right now, the way that I have this equation written, I've got the 0.64. I need to zero that out because it's on the wrong side. So I'm going to zero out my 0.64 by subtracting it, but I got to do it to both sides, of course. So that does zero that out. I'll drop this 0.9x, which equals... yeah, we'll drop the 1.3x. We'll get to it. And then subtracting that should be a positive 2.24. That one set up pretty nice. I didn't have to borrow or carry anything, so I just actually used kind of long subtraction on that one. Well, now I've got the 1.3x. It's on the wrong side. It's on the numbers side of thing, the constants. So I'm going to have to zero that out as well. Subtract 1.3x. from both sides makes that negative 0.4x, which now equals this 2.24. Well, I do not want, I'm sure you don't want it either, but negative 0.4x, I'd rather have 1x, so I'll divide 0.4 by itself. But again, whatever you do to one side, you got to do to the other side. So I will need the calculator for this one. 2.24 divided by, we'll say that's a negative 0.4, negative 5.6. So x equals negative 5.6 on that one. And you know, I'll go ahead and check here real quick. I'll use the calculator. So that shows that when x equals negative 5.6, it is definitely a true statement. Not that I'd want to do all that in my head or longhand, but the calculator is a nice resource for that to make that go really smoothly.